Hey everyone, welcome to CAIE Science. Today we will be solving February March 2023 for 229701. So let's begin. Question number 1. The Pauling electronegativity values of elements can be used to predict the chemical properties of the compounds. Okay. Use the information in the table 1.1 to answer the following question. Define electronegativity. So it's actually the ability of an element to attract electrons to itself. Okay, or you can say an ability of an atom. So ability of an atom to attract electrons to itself. Okay, now oxygen and sulfur are in group 16. Okay, explain the difference in the Pauling electronegativity values of these oxygen and sulfur. This is your oxygen and this is sulfur, and electronegativity of oxygen is 3.5 and sulfur it's 2.6. So if you see in the periodic table, this oxygen is above this sulfur. So and you can see that there is these are in different periods. Okay, that this oxygen is in second period and this sulfur is in third period. So this oxygen has two shells and this sulfur has three shells. So the distance between the nucleus and the outer electrons increase in this sulfur. So the ability of this nucleus to attract the electrons will decrease because there is more, you can say, more space or distance between the nucleus and the outer electrons. Let's say this is your nucleus and this is the outer shell in oxygen. So and this is the nucleus of sulfur and the outer shell of sulfur is like this. So this distance in sulfur is greater. So its electronegativity value is lower than this value of this oxygen. Okay, because this oxygen in oxygen the shell is closer to this nucleus. Okay, so what will you write? Oxygen has fewer shells, fewer shells than sulfur. Okay, so greater fraction for nucleus in oxygen. Okay, now part B, the lithium hydride is an ionic compound. Draw this dot and cross diagram of LiH. Okay, so you have hydrogen, and if you see lithium has three protons, so it must have three electrons as well. So lithium has three electrons, and hydrogen has only one electron. But when this lithium hydride forms, this is an ionic compound. Okay, so this lithium will lose one of its electrons. Okay, so in lithium you have to show all of the electrons. Okay, so lithium, this is lithium, and when it forms ionic compound, so it will have only two electrons. One electron is lost to this hydrogen. Okay, so it will have a plus charge, and then you have, oh, hydrogen. Hydrogen has only one electron. Okay, that's, so this is cross, and one electron is gained from lithium, so it also completes its octet. Okay, and it will have a negative charge. So this is your ionic bonding, your dot and cross diagram. Okay. Now suggest the shape of the molecule H2S. So now you have to first find sulfur. Sulfur is in group 16. Okay. So it must have 6 electrons in its outer shell. Okay. 6 electrons in its outer shell, and 2 of the electrons are bonded. Okay. Hydrogen forms a single bond. So sulfur must bond. 2 of the electrons are bonded to hydrogens. Okay. Now 4 electrons are remaining. So these 4 electrons will be as lone pair. So the shape will be like this, bent shape. Okay. Bent shape, or you can say a non-linear shape. Okay. This is your bent shape. Now part C, write an equation that represents the first ionization energy of hydrogen. So the definition of ionization energy is the energy change when 1 mole of gaseous atom changes into 1 mole of gaseous ions. Okay. So when gaseous hydrogen atom loses one of the electrons, it forms gaseous ion. Okay. So this is the first ionization energy of hydrogen. Explain why there is no information given in the table 1.1 for the second ionization energy of hydrogen. In table 1.1, you can see that there is no second ionization energy of hydrogen because hydrogen has only 1 electron. So there are no more electrons. So it has no second ionization energy. Okay. So has only 1 electron. Okay. Hydrogen has only 1 electron. Okay. Now give the full electronic configuration of sulfur 2 plus. Okay. So you can see that sulfur has 16 protons. So it must have initially sulfur must have 16 electrons. So and it loses 2 electrons to form 2 plus. So now it will have 14 electrons. So let's write the electronic configuration: 1s2, 2s2, 2p6, 3s2, and 3p2. So this is your electronic configuration of sulfur 2 plus. Okay. Now part D, carbon dioxide and sulfur dioxide are acidic gases. Write an equation for the reaction of sulfur dioxide with water. So when sulfur dioxide reacts with water, it actually forms sulfurous acid. Okay. So it forms H2SO3, not SO4. It would be sulfuric acid, but it forms sulfurous acid. Okay. Now when sulfur dioxide reacts with NaOH, it forms sodium sulfite. Okay. So in SO2, sorry, SO3 plus H2O. Okay. Now construct an equation for the reaction of carbon dioxide with magnesium hydroxide. So it forms magnesium carbonate, magnesium hydroxide. Okay. So it will form magnesium carbonate plus water. Okay. Now moving towards next part E. So complete the table 1.1 by placing a tick to show which of the compounds have a molecule with an overall dipole moment. So you have to find the molecules with overall dipole moment. So if you see in carbon is in group 14. So it has 4 electrons in its outer shell and 4 of the electrons are bonded. So it will have a linear structure like this. Okay. So this carbon is positively partial positive and and this oxygen is partial negative, and this oxygen is also partial negative. So these both will try to attract electrons to themselves, but with the equal forces, so overall dipole will cancel out, so it will not have a dipole. Now see this sulfur. Sulfur is 16, is in group 16, so it has 6 electrons, and 4 of the electrons are bonded. So there is one lone pair. Okay, so it will have a shape like this. So there is a overall dipole moment. Okay, dipole moment does not cancel out, so it will have a dipole moment. Now see this carbon. This carbon will also have a same case as this oxygen, so no dipole. Now check out this carbon. This carbon has a shape like this, but you can see that oxygen is more electronegative than sulfur. They will both attract the electrons, but oxygen will attract more, so there will be an overall dipole. Okay. Now moving towards next part. At 150 degrees Celsius and 103 kilopascal, all the compounds listed in table 1.2 are gases. Okay, under these conditions, 0.284 gram of one of the compounds occupies a volume of 127 cm3. Use this information to calculate the MR of the compound. Hence, identify the compound from those given in table 1.2. Okay, so you have to find the MR and then you have to identify the compound from table 1.2. So PV is equals to nRT, and you have to find the MR. So this mole is equals to mass upon MR. PV is equals to mass upon MR RT, and you have to find the MR. So MR is equals to mass multiplied by R multiplied by T and PV. Now you have to be very careful with the standard units. So for the PV is equals to nRT, the temperature must be in Kelvin, this volume must be in meter cube, and this pressure must be in Pascal. But you can see that this pressure is in kilopascal. So mass, you have the mass must be in gram. So mass is in gram 0.248, and the value of R is given in the important values on the last page, which is 8.31. So 8.31. Now this temperature must be in Kelvin, but it is in degrees Celsius, so you have to convert it into Kelvin. So you will add it into 273. Okay, now divided by pressure. So pressure is in kilopascal, so you will multiply by 1000 to make it in pascal, and then you will have volume is in cm cube, so you have to bring to meter cube, so you will multiply with 10 to power minus 6. Okay, so from here you will find the MR, and MR is, if you calculate from the calculator, you will get 76.3. Okay, and if you calculate this carbon TSO2, this carbon has a mass of 12 and sulfur has mass of 32, I guess. Yes, 32. So 32, 64, and this will have a mass of 76. So the compound, it's CS2 and MR is 76.3. Okay, so that's how this question is completed. Now moving towards next question number 2. The group 2 element magnesium to barium are all silvery white reactive metals. Draw a label diagram to show the bonding and structure to the group 2 metals at room temperature. So group 2 metals are metals, so and in metals you have metallic bonding, so you have to show the metallic bonding like this. So this is your metallic bonding. It's actually the lattice of positive ion in the sea of electrons. Okay, so these are your free electrons or delocalized electrons. Free electrons, or you can say delocalized electrons, and these are your ions, positively charged ions. Okay, now explain why magnesium has higher electrical conductivity than sodium. So if you see the sodium when it forms ion, it forms sodium 1 plus plus 1 electron, and when magnesium forms ion, it forms magnesium 2 plus plus 2 electrons. So each magnesium atom loses 2 electrons, and each sodium atom loses 1 electron. So there are more electrons released in magnesium, so it must have a greater conductivity. Okay, so magnesium has more free or delocalized electrons. Delocalized electrons. Okay, now write an equation for the reaction of magnesium with cold water. So when magnesium reacts with cold water, it forms magnesium hydroxide plus hydrogen gas. Okay, now identify a single reagent that can be used to distinguish separate samples of dilute magnesium nitrate and dilute barium nitrate. Explain your answer. So you have to distinguish these compounds. So if you remember the hydroxides, OH and sulfates, the solubilities of these hydroxides and sulfate increase or decrease down the group. So the solubility of hydroxide usually increase down the group, and this solubility of sulfate decrease down the group. Okay, decrease down the group. So barium sulfate is actually insoluble. So if you react any compound which contains sulfate ions, so it will form barium sulfate, and it will give a PPT, white PPT. Okay, so let's say I'm taking sodium sulfate. Okay, sodium sulfate, sodium sulfate. Okay, so this barium sulfate, barium will give a white PPT. Okay, so barium sulfate is insoluble and will give a white PPT. Okay, white PPT or white precipitate. Now part D, describe what is observed when this strontium iodide reacts with concentrated sulfuric acid. Okay, so this reaction is similar to this reaction of uh, sodium chloride or sodium iodide with concentrated sulfuric acid. So when this strontium iodide reacts with concentrated sulfuric acid, it will form strontium strontium hydrogen sulfate plus Hi, and this hydrogen iodide will further react with sulfuric acid to form sulfur dioxide plus water plus iodine. Okay, and it will also form this sulfur plus water plus iodine. Okay, this will be the iodine gas, and these iodine will be in vapor form, and this will be in solid state, and this will also form H2SO4, and it will also form H2S plus water plus iodine. Okay, so this is yellow ppt. It will give a yellow ppt and it is a black solid. So there are multiple things that you can write. Okay, um, so you will write what will you observe. This there will also it will also produce a this purple vapors yellow solid. This is yellow solid. Okay, so there are multiple things. So you will firstly you will see the effervescence. Okay, effervescence, effervescence, and yellow solid. This is sulfur is a yellow solid. Okay, and dark solid. Okay, gray solid, dark gray solid, or black solid, you can say solid, which is iodine. Okay, iodine is a black solid or dark gray solid. So these are your observations. Now compound X, an anhydrous group 2 bromide, is dissolved in water and titrated against silver nitrate. Okay, a solution containing 0.25 gram of X requires 33.65 gram of 0.05 mole per dm cube of silver nitrate for the complete reaction. Identify the X. You have to find the X. So it's actually group 2 bromide. So if I write the equation XBr2, this will be the formula for this bromide. This will react with silver nitrate to form silver bromide plus XNO3 NO2 NO and this nitrate. This will be the your equation, and you have to balance the equation. So it will be uh, like this. Balance the equation. Okay. So now you can see that this bromide and silver nitrate are in 1:2. That was an important thing which you have to understand. So that's why I wrote the equation. Okay. So now firstly we found the moles of silver nitrate. Okay. So it's actually C is equals to N is equals to CV. So you have concentration is equals to 0.05 multiplied by 33.65 but divided by 1000 because you have to convert it into dm cube. Okay, so it will form 1.6825 into 10 raised to power minus 3. Okay, now from ratio you will find the moles of this bromide. So moles of XBr2 is equals to 1.6825 into 10 raised to power minus 2 divided by 2. So it will form 8.4125 into 10 to power minus 4. Okay, and now you have moles and the mass is given to you, the mass of X. So you will find the mr of X. Mr is equals to mass divided by moles, 8.4125 into 10 to power minus 4. So the mr will be if we calculate, the mr will be 297.2. Okay, so now the mr, you have calculated the mr. Now you have to find the X. What is the X? So you actually have to find which group 2 element this X has. Okay, so if you see this XBr has this formula, and so there are two bromines. So if you calculate the mass of bromine, this bromine has a mass of 79.9. Okay, so if you multiply this bromine Br2, it will have a mass of 79.9 multiplied by 2. So it will give you a mass of 150 9.8. So if you subtract this 297.2 minus 159.8, you will get the mass of the group 2 element. So it's actually it will be 137.4. And if you see from the periodic table, barium has a mass of 137.3. Okay, so this is barium. Okay, and what will be now x will be barium bromide. Okay, barium bromide. Okay, that's your x. Now moving towards next question. Question number 3. Alkenes undergo an addition reaction with a 1,1 mixture of carbon monoxide and hydrogen to form aldehydes. Okay, figure 3.1 shows the reaction of propene with 1,1 mixture of carbon monoxide and hydrogen. Okay, define an addition reaction. So it's actually a reaction where two or more compounds or elements, reagents, react to form one product. Okay, a reaction in which two or more reagents sorry, this is reagents react to form one product. Okay, now aldehydes A and B are structural isomers. Okay, state the type of structural isomerism shown by A and B. So if you see, there is a chain isomer 1 2 3 4, 1 2 3 4. So it's actually the chain isomerism. Okay, chain isomerism. And if you see, yeah, it's a chain isomerism. Okay, now name what is A? 1 2 3 4. So it is actually butanol. It is an aldehyde and it has 4 carbons, so it is a butanol. Now complete reaction for the propene with 1,1 mixture of carbon monoxide and hydrogen produces A and B only. Okay, the product's mixture contains 96% of A and 4% of B. Calculate the mass of A produced in this reaction when 5 into 10 to the power minus 3, which is actually 5,000 kilograms of propene is used. Okay, so the A is produced in 96 percentage. Okay, so firstly let's find the MR of propene. So propene is actually C3H6, so it will have a 12 into 3 and plus 6, so 43 plus 4, sorry, 42. It will have a mass of 42. And if you see, what is the mass of this A butanol? 1 2 3 4. So C4H8O. So 48 plus 8 plus 16, so it will be 72. Okay, so now you have to, firstly we will find the this moles of this propene. Okay, so the moles of propene will be this 5,000 divided by 42. Now these will also be the moles of this C4H8, because this C4H8 is the only product, although this A and B are in proportions of 96 proportion and 4 proportion, but they both have same molecular formula, which is C4H8. So C4H8 is actually, the moles of C4H8 are same, so these are the moles of C4H8. So you will find the mass of C4H8 by multiply it with this Mr. Okay, so you will get the mass of, this is your mass of this C4H8 which is produced. Now this mass, in this mass you have 96 percentage of A, so you will multiply it with 96 percentage to get the mass of A which is produced. Okay, so you will have a mass of approximately 28230 kgs. Okay, this is the mass of A which is produced, 8230. Now part B. A and B show reactions typical of aliphatic aldehydes. Sorry. A undergoes a nucleophilic addition reaction with a mixture of HCN and KCN, forming compound C. This is your compound C. So complete the diagram to show the mechanism of this reaction. Okay, so you have to show the mechanism. This mechanism is very important and very interesting. So you have to remember this. Okay, include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Draw the structure of organic intermediates. So firstly, this HCN, this KCN is actually behaving as a catalyst. Okay, so HCN, so this CN has a lone pair. Okay, carbon of this. So and this oxygen is electronegative, more electronegative than carbon, so it will form partial positive and partial negative, and this oxygen will attract electrons to itself, and this will be partial positive, so this lone pair of electron will attract, sorry, will attack this carbon. Okay, so this carbon, this double bond will be break down and it will form oxygen negative, and it will have a lone pair, and this cyano group will be attached. Okay, C3H7. Now this cyano group is attached. Now this hydrogen H plus, there is an H plus over here, so this H will now be attracted by this lone pair. Okay, so it will this lone pair will be attracted by OH, so it will form this C. Okay, so this is an addition reaction. Now table 3.1 shows information about 3 experiments involving B. This B, so B is actually 1 2 3. Okay, so let's draw this 1 2 3. This is an aldehyde and it has a branch over here. Okay, this is your structure of B. Okay, now when this B is reacted with different reagents, okay, complete the table 3.1. So when B is reacted with a reagent, the reagent solution turn from orange to green, so it must be orange, it must be an oxidizing agent, and it is this acidified potassium dichromate. Okay, so when this aldehyde reacts with acidified potassium dichromate, it will form carboxylic acid. Okay, acidified potassium dichromate, K2Cr2O7. Okay, now forms a silver mirror form on the sides of the reaction vessel, so it must be a silver nitrate. Okay, or Tollens reagent, you can say Tollens reagent, which is a silver nitrate, alkaline silver nitrate. Okay, Tollens reagent. So now this bromine, when this reacts with bromine, there will be no change because there is no double bond in this aldehyde. You can see that, so no change. This bromine will decolorize when there will be an alkene. but there is no alkene, so no change. Now B is oxidized by acidified potassium magnate 7. Okay, so it will also form carboxylic acid. Complete the equation for the reaction. Use O to represent one atom of oxygen from the oxidizing agent. So when this reacts with oxidizing agent, it forms butanoic acid. Okay, now moving towards next part, part 4. C is a chiral molecule. Okay, circle any chiral centers in the structure of C, shown in figure 3.2. So if you see, this is your chiral carbon. You have to circle it, and there is no more chiral carbons. Okay, so this was the only chiral center. Now C, part C, when propene reacts with carbon monoxide and an excess of hydrogen, an alkane, and mixture of alcohols are formed instead. The alcohols are isomers of each other. Suggest a molecular formula of the alkanes and alcohols that are formed under these conditions. Okay, when this carbon monoxide reacts with propene, it will form an alkane which is propane. Propane, okay, propene to propane, because two of the hydrogens will attach. Okay, so it will form a propane, and propane has a, sorry, you have to write the molecular formula. So propane has a molecular formula of C3H8, and when this propene reacts with C carbon monoxide, it forms alcohols. So alcohols must have one more carbon. So they must have be butanol, for suppose butanol, because it forms this aldehyde, which is butanol. Now it's saying it forms a mixture of alcohols. So they must be butanols. Okay, let's say for example, and this butanol has a molecular formula of C4H10O, or you can also add C4H9OH. Okay, now part D, the reaction of ethene. But this molecular formula is not necessary. This is the correct one. Okay, C4H10O. D, the reaction of ethene with an 101 mixture of carbon monoxide and hydrogen is shown in equation 1. Okay, now at atmospheric pressure, a cobalt-based catalyst is used in this reaction. Study and explain the effect of using catalyst on this reaction. So, what will be the effect of catalyst? Catalysts actually increase the rate by providing an alternate route pathway with a lower activation energy. Okay, so catalyst catalyst increases the rate of reaction by providing an alternative reaction pathway of lower activation energy. Okay, now part 2, explain why the yield of this C3H6, this butane 123 propanol, sorry, it's actually propanol increases when the overall pressure of this reaction mixture is increased. So why this yield increase when the pressure is increased? You can see that there are 3 moles of gas, okay, on the left hand side, and there is only 1 mole of gases on the right side. So if you increase the pressure, so the equilibrium will shift to the right side. Okay, that's why the yield decreases. Okay, equilibrium move to the right side. There are there are fewer gas moles on right side. So equilibrium shifts to the right side, to the right side. Okay. Now use the information in table 3.1 to calculate the enthalpy change of this reaction in equation 1. Okay. So the enthalpy changes of formation are given in table 3.1. So firstly we will draw a cycle C2H4 plus carbon monoxide and hydrogen. It forms C3H, sorry, CH3, CH2, C, CHO, sorry, CHO. So this will this is the your enthalpy change of reaction which you have to find. Okay, and you are given the enthalpy change of formation. So enthalpy change of formation, you have to remember the definition. It's actually the enthalpy change when one mole of ionic or one mole of compound is formed from its elements in a standard states. So this carbon and hydrogen gas and oxygen gas. So if this carbon and hydrogen react these elements, if they form this ethene. So this is the enthalpy change of formation of ethene, which is 52. And for the carbon monoxide, it's actually minus 111. And there is no enthalpy change of formation of this hydrogen. But the enthalpy change of formation of this propanol is minus 187. So now the cycle is ready. So you will find this enthalpy change of reaction. So enthalpy change of reaction is equals to this 552 minus 111 is equals to minus 187. Okay. So this enthalpy change of reaction is going to be minus 1 minus 128. Okay. So this is your enthalpy change of reaction minus 128. Now the reaction mixture is cooled to collect the propanol as a liquid. Identify all the types of van der Waals forces that are present between the molecules of butanol. So if you draw this structure CH3, CH2, this butanol has both this induced dipole forces and permanent dipole forces. Okay, so induced instantaneous instantaneous dipole, induced dipole, and permanent dipole forces. Okay, dipole forces. Okay, now moving towards next question, which is question number 4. This question number 3 was a big one, total of 21 marks. Okay, now question number 4. Figure 4.1 shows some reactions of compound D, which is 2-bromobutane. Okay, so part A. State the reagents and conditions used to form E in reaction 1. Okay, so react E. So this halide, this halogenoalkane is changed into alkene. So what are the conditions? It is actually the sodium hydroxide and ethanol. Okay, and heat under reflux. NaOH in ethanol, you have to remember the conditions, okay? In ethanol and heat under reflux. Heat under reflux. Okay. Now draw the structure of one repeat unit of the addition polymer that forms from E. So 1, 2, 3, 4. So it's actually this double bond will change into single bond. So this repeat unit will be like this. PH3. This double bond will break down into like this. Okay. So this is your repeat unit. Now E, sorry. Now E also forms when F is heated strongly in the presence of aluminum oxide catalyst. Okay. This is E. E is also formed when F is reacted with an aluminum oxide. Write an equation for this reaction. F 1, 2, 3, 4. So this C4 H10O, when this butanol is when this butanol reacts with aluminum hydroxide, aluminum oxide catalyst, it will form alkene C4H8 plus water. Okay. Now moving towards part B, predict what is observed in reaction 2. What is reaction 2? This is reaction 2. So silver nitrate in ethanol is reacted. So this silver nitrate will form silver bromide. So, and silver bromide is a cream PPT. Okay. So this will be your observation. Cream PPT. Cream PPT. Or cream precipitate, you can write it. Cream precipitate. Now identify a yellow precipitate and the organic ion formed in reaction 3. Okay, in reaction 3, you have reacted this alcohol with alkaline iodine. Okay, so there is a methyl group with the attached with this carbon which has functional group attached, so it will form a yellow precipitate, and this yellow precipitate is of triiodomethane CHI3, and this an organic ion will be 1, 2, 3, so it will be propanoate. Okay, this alcohol will be oxidized to propane this alcohol carboxylic acid, but there will be one less carbon. Okay, so this yellow precipitate is CHI3, or you can say triiodo triiodomethane, triiodomethane, and the organic ion will be CH3 CH2 C double bond O, or you can say propanoate ion. Propanoate. Okay, so this would be a propanoate. Now part C, state the type of reaction that occurs in reaction 4. Type of reaction. So this is this is reaction 4. So Br is exchanged with Cn. So it's actually a nucleophilic substitution reaction. Okay, so nucleophilic substitution. Nucleophilic substitution. Substitution reaction. Okay. Now reaction 5 is similar to the reaction of this LiLH4 with carboxylic acids to form alcohols. Reaction 5. This is reaction 5. This Cn is changed into this amine group. Okay. So now suggest the role of LiLH4 in this reaction. So it's actually reducing agent. Reducing agent. Reducing agent. Okay. Now part D. This figure 4.2 shows the infrared spectrum of one of the compounds D, E, F, and G or H. So these are your D, E, F, G, H. Okay. So we have to find which this spectrum is of which of the compounds. Okay, which compound has this spectrum. Okay, use the information from the table 1 4.1 on page 14 to identify which of the compounds D, E, F, G, or H produce the infrared spectrum in figure 4.2. So firstly, let's analyze your this is your table 4.1 actually. Now you have to analyze the peaks. So you have the peak at this range 200, and this is this peak. This is peak is at 2200, in the range of 2200. So this peak is of this nitrate compound. Okay, so from here you can identify that this contains an CN group, and if you see which one of these compound contains CN group, D does not contain CN, E does not contain CN, F does not contain CN group, G contains CN group, and H also does not contain cyano group. So it must be a G. Okay, G. You can also analyze this peak at 3000. So this peak at 3000. So this must be due to um, can say this will be due to an alkane. Okay, this is not uh, this is below this 3000. Okay, so it is from 2800. Okay, so this must be due to this CH group. Okay, so this is actually a G. Okay, so G, so it's G because absorption at 2200 to 2200 to 2250. Okay, cm cm cube minus cm minus 1. Okay, of this cyano group. Okay, that's why it's G. Now moving towards next part. In the mass spectrum of D, so this is your D, 2-bromobutane. Let's draw a structure 1 2 3 4. 1 2 3 4. Okay, 1 2 3 4 3. 1 2 3 4, and there you have bromine. Now in the mass spectrum of D, the relative abundance of the molecular ion peak is 3.4. Predict the relative abundance of M plus 2 peak for this D. So this M plus 2 peak is actually due to the halogen, and the halogen will be Cl or Br. Okay, chlorine or bromine. So there is bromine, and in bromine you must remember that this abundance of bromine 79 and bromine 81 is approximately 50. Okay, they both have same percentage abundance. Okay, so the relative abundance of M plus 2 peak will also be this 3.4. Okay, because the abundance of this Br is 50:50. Okay, but if you remember, you have to also remember that if it would be a chlorine 35 and chlorine 37. This chlorine 35 and chlorine 37. This 35 is a percentage of 75 and 25. So these are in 3:1. Okay, but these are in 1:1, so they will have a same abundance. Okay, but they will have a different abundance. Okay, so this this must be there is a bromine, so this M plus 2 peak will also have a same abundance. Okay, so this will be abundance will be 3.4 because the relative abundance of bromine 79 ratio bromine T1 is approximately equals to 50 ratio 50. Okay, or you can say 1 ratio 1. Okay, that's why they both have same uh, abundance. Now that's all for the day. I hope you like the video, and if you haven't subscribed my YouTube channel, do subscribe the channel for more videos and more papers related to chemistry, IGCSE, A levels and O levels chemistry. Thanks for watching, and see you in the next video.